Hi everyone, today we're going to find out how to calculate volume. Now you've done a little bit of this before when you were counting cubes. Volume just means the amount of space taken up by an object. So it kind of goes along the same lines as when you were calculating perimeter and then you were calculating area, which were for flat surfaces. Now, when you find the volume, you're actually looking at three-dimensional shapes. It's a measurement for three-dimensional shapes. How much space does the object take up? So in an odd shape like this, you would just count the cubes. So 1, 2, 3, 4, 5, 6. So the volume of this is 6 cubes. Now, you're going to start working with actual standard measurements now. So we know that this tiny little cube here is called a centicube. And the reason it's called a centicube is because each side measures 1 centimeter. So how I would calculate the volume of this tiny cube is I would be looking at the length of it, which is 1 centimeter, and then the width of it is 1 centimeter, so I'm going to multiply those. And then the height of it is 1 centimeter. So when we learned last about calculating the volume of something like a rectangular prism, we learned that what we were doing is we were looking at the area on the bottom, which was the length times the width, so the length times the width here, and then multiplying that again by how many layers there were. And that's where I'm getting 1 times 1 times 1. It's the length times the width and then the height. Okay, and this is exactly the formula you're going to use for all rectangular prisms or cubes. So therefore, if I multiply all those numbers together, this centicube is 1 centimeter. Now, because I'm multiplying that unit 3 times as well, we're going to use a little 3, and that means centimeters cubed or cubic centimeters. So when we calculated area, which was a flat shape, a two-dimensional shape, or like a rectangle or a square, and we just did length times width, we were multiplying 2 numbers together, and that unit was multiplied twice, so you put that little 2 there to show square centimeters. All right, in a 3D figure, like a cube or rectangular prism, we have to use this little 3 to show cubic centimeters or cubic millimeters or cubic meters, whatever your measurement might be. All right, so then I'll give you another example, and this will be in real life measurement because these actually do measure 1 centimeter. So we can see that it is 2 centimeters now so that's the length, and the width is also 2. So this is a perfect cube, so that's why it's coming out to all the same measurements times 2 for the height. So 2 times 2 is 4, and then times 2 is 8. 8 centimeters cube, or 8 cubic centimeters. So this is an example of a cubic centimeter, and if I were to take this all apart, okay, which is stuck together a little bit, but if I were to take this cube all apart, then I do actually see that there are 8 cubic centimeters that I use to make that. 1, 2, 3, 4, 5, 6, 7, 8. So that's kind of deconstructing it a bit for you so you can visualize how I'm getting these numbers. But what you're going to remember is to find the volume, it is length times width times height. So here we go. I'm going to show you an example now here of some of the diagrams you might see in your book. So they won't actually necessarily need to draw you a picture showing all the cubes anymore once you've got the hang of it, once you've got the hang of using the formula. So they may just give you the prism like this in a model and then just label the length and the width and the height, or they may not even give you a model and they may just tell you what the length, width, and height is. Either way, you'll still be able to find the volume. As long as you know these 3 things, you can find the volume. You'll be able to find out how much space it takes up. All right, so here I have a length of 3 and a width of 2.5 and then a height of 5. So once you get into decimal numbers and even numbers that are a little bit higher, you may want to do those separately. So I'm just going to remind you how to multiply with a decimal. And I would always recommend standard algorithm here, putting it in a tower. So 2.5 times, now when we multiply the 3, you can just put the 3 right here. When we add decimals, we like to line up decimal places, but in multiplication it's different. You can just put the 3 there, and it does not matter where the decimal is because that doesn't factor in until the end of your math. So 5 times 3 is 15. We're going to regroup. 2 times 3 is 6 plus 1 more is 7. And then I'll know where to put the decimal by counting how many decimal places are in this whole question. So because I see 1 decimal place right here, I know that I'm going to have to move 1 decimal place right here. And so that's 7.5. So far the length times the width is 7.5. Now I'm going to multiply it by 5. So again, you can do this in steps just to make it easier for yourself and make sure that your math is accurate. 5 times 5 is 25. 7 times 5 is 35, plus 2 more is 37. Okay, again, I'm looking to see where would that decimal go. Well, I can only see 1 decimal place in the question right here, which means that I also go 1 decimal place for the answer. And the total volume is 37.5. So volume equals 37.5. And remember, centimeters cubed. Really important to remember to use the cubic unit for a volume. All right, so don't forget that little 3. If with your unit, either centimeters or millimeters or whatever unit they're giving you, make sure you use that little 3 there to show volume. All right, so have good luck today. Work carefully through your calculations, and I think you'll do great.